Hi there, Tim Fairfield, Keysight Technologies. This will be part one of a practical TDR series, and the focus of this first video is calibrating the system and understanding how to account for adapters when connecting the remote head to a Dut. Today, I'm going to do a walkthrough of how to set up the N1055A TDR remote head for use as a TDR or time domain reflectometer. This allows us to look at impedance on a channel and also save S parameters for embedding or de-embedding channel loss. And this is what we're looking at right here. I've got it connected to a channel and we can see impedance changes through here. I'll show you how to get this display. I'll show you how to find out on the reference frame where we're at, what we're doing. So let's get started. So before you even get started with any new unit, when you plug a new unit into the chassis, you will be faced with having to do a calibration, frame calibration. Let me just simulate this. What I'm going to do is I'm going to unplug the module and move it to a different slot, and there'll basically be a request there for us to do a calibration. And let's get started. Okay, let's go to calibrations. It gives you a warning. We need to do a module calibration and vertical calibration, the TDR step calibration. So I'm going to do a full calibration, including the TDR step calibration. And when we go to calibrate, we're going to be walked through the calibration procedure, which is very easy to do. Say calibrate. So important, you must disable or disconnect any sources and for optimal results, connect a load or any adapters necessary for the measurement. I'm not going to use a load in my measurement. For this initial module calibration, I'm going to remove everything. The calibration is doing a vertical cal, and it will go fairly quickly. So we'll let that run. Okay, remove all cables, adapters, and standard from channel 2A. So I've already done that. I'm not using these loads in my particular measurement. So we're open again. Again, this is a quick process. Connect a 50 ohm load 2A. So I'm going to go do that. All right, and do that again. I will connect a 50 ohm load to B. Next, 2C will now get a load. So load is on 2C. And 2D final. I've connected a load to 2D. So everything will be removed from all of the channels. I'll go do that now. Okay, and we are complete the module count. So next up, tools. TDR step calibration has been done. Everything's been done in this section. Now we need to go into the TDR setup menu. So we'll advance to that next. Now we're in the TDR setup section. Let's go through this. We want to talk about the Dut setup that we were presently using. You must connect each one. I'm going to use 2A and 2C, and I'm only going to do a single-ended. Now, if you're doing, we're going to connect here and 2C, 4. And you could select auto connect and let it do it. If we did that, we can also remove. We make a mistake. We don't. Let's auto connect. Okay, this is how we can go about this. I'm only going to connect the 2. I'm only going to calibrate half of this or use half of this because we're only going to do a single ended. But yes, you can definitely, if you're doing differential, you need to do all 4. Just a side note here, I chose to use this Dut layout. There are a lot of options in here. You could choose to do a different Dut layout altogether. Single-ended mode here. You can also do the single-ended and just use half. The other thing you can do is go differential. So you can have a differential signal, and if I switch to single-ended, then there's a 4 single-ended as well. So there's lots of different options in here, but I'm not going to focus on that in this video. I just wanted to make the point that within this video, I've chosen to go a particular way, but there's plenty of other options. We can use a saved calibration that we've done before. That will save us time. I'm going to do a new one, new calibration, and verify Dut connections. You're going to verify this is how you're going to be connected to your Dut, and that's how we're going to do it. We're using the Ecal, the electronic calibrator. You do have the option of short open load through or the short load through hardware to do that, but I'm not using that. I'm using the Ecal because it's a heck of a lot faster and highly recommended because it just makes life a lot easier. You don't have to keep connecting and disconnecting. Now, if I didn't have the Ecal connected, right now I do. Let me unplug it and show you what happens when I unplug the Ecal. It's going to give us a warning if I try to use it. I've disconnected the Ecal. I've just pulled out the USB, and that shows that there's no Ecal module detected. Unless I connect one, it's not going to work. I'm going to plug it back into the front of the port, and we'll watch this change again. Sometimes you need adapters for both the TDR heads and the Ecal module, which means there are two cases to consider. Choosing the adapter for the TDR heads is always easy for everyone. Just choose the adapter that enables the user to connect the head to the Dut. That means the TDR head plus the head adapter will connect directly to the Dut. The easiest way to look at things is to choose adapters for the Ecal. So the Ecal plus the Ecal adapter have the same connector as the Dut. That way, when you disconnect the TDR head plus adapter from the Ecal after TDR calibration, you can connect the TDR head plus the head adapter directly to the Dut without the need for any additional adapters. The calibration reference plane is at the end of the adapters on the TDR head and the end of the adapters on the Ecal module right here. The particular Ecal module that I have has a male on both sides. Now, the Dut connectors, how are we going to be connecting to our Dut? If I'm connecting into the board, the particular demo board I have has male connectors. The N1055A has the option of having a male or female connectors on it when you order them. I happen to have the female end on mine. That means that I do not need an adapter in this situation. Now it's time to select the connectors. Now on the Dut, I have two different Dut boards, so I'm going to show both of them. The first one is a 2.4 millimeter male connector. So I'm going to select that in the Dut connectors. 2.4 millimeter male, that's what's on the Dut. The Ecal must also match that. My specific Ecal module is outfitted with a 2.4 millimeter male connector, so I don't need to do anything here. The second thing is whatever adapters I need to stick on my TDR head, I will put them on. They aren't accounted for in here because the reference plane is at the end of the TDR, the adapter on the end of the TDR. In my case, I have a female connector, 2.4 millimeter, on my N1055 head. That means I can directly first connect to the Dut, and secondly, for calibration, I can connect it direct to the Ecal. There's really nothing to do. No adapters are needed. The other situation I have is I have a board that's a 3.5 millimeter female connector. So if I'm going to test on that board and specify cal kits, I'm going to have to change a few things. I'm going to have to, first of all, select the Dut. So the Dut here is a 3.5 millimeter female. As soon as I select that, we get an error up here. The Ecal module and the Dut do not have compatible connectors. They have to match. That's exactly what it's saying. So we need to next go to the Ecal options and choose an adapter that looks like an SMA female. So essentially we have to go from 2.4 millimeter to 3.5 millimeter female. And because it's a male that's already on the Ecal, I have to go female 2.4 to female 3.5. So let's add that adapter. Let's go. So we're looking for 2.4 female to 292 female. That one should work. And we're done. Now, if we were to needed to add any adapters onto our TDR head, which we will, we select that connector, put it on there, but we don't specify that in this calibration. That just needs to be there at the end of the adapter on the TDR is where the reference plane is. And then we can continue. I'm going to go back to the situation I had before. Remember, we're a 2.4 millimeter male on my Dut. And now I have to remove this. We put none. We don't need that anymore. And we are good to go. So we will be connecting directly to a 2.4 millimeter male Dut, and we can continue on. And then we can start the calibration. I'm going to start the wizard. Connect channel 2A to the Ecal. A few things to remember. Make sure you're using the torque wrench, and most importantly, these are static sensitive. I have an anti-static mat. I have a wrist strap. It's also connected to ground. Okay, I have them connected. 2A and 2C are connected. Let's do a measurement. There's 15 steps here. That took about a little over 2 minutes. I think on the newer modules, it probably will run faster. The calibration has completed successfully. So I've connected up to my Dut, and let's get started. Let's go to TDR TDT. Let's do a time domain analysis. Oh, we do have to turn on the step. There we go. If we do not turn on the step, things don't happen. We'll go into the time domain displays and let's say select all, close. And we want to run this, run. We can auto scale this and we can change the time domain. We can move this. If we mouse wheel over this, and as well, we can manually change the time base. If you click in here, 200 picoseconds, change that, for instance, like that. Okay, and we'll get a display similar to that. This concludes part 1 of this series. The next part of the series, we'll talk about dielectric constants. We'll talk about automated fixture removal, and we'll look at saving S parameters as well. Don't forget to subscribe and like, and we'll see you next time.